If you're a beginner or intermediate Python programmer and you're looking for some short, fun, yet interesting projects to work on, then this video is for you. What I'll be doing is showing you 3 unique Python projects, and I'm going to walk you through the entire process from the beginning to the end. That means that I'm going to be coding these completely from scratch. I haven't attempted them, I haven't looked at them yet, and you're going to be able to see my entire thought process, how I break down the problem, how I attempt to come up with a solution, and how I deal with any problems or bugs that occur in my program. Hopefully you guys will find that valuable, and it will make it a lot easier for you to go work on your own projects or to extend these afterwards. Now, what are the projects we're going to build? Well, they will be time-stamped down below, but the first one is a pig game. Now, this is kind of a dice rolling game where you roll until you get a 1, and then the next person gets to go. Then we're going to work on a Madlibs generator. This means we're going to have a story with a bunch of words that we're going to ask the user to fill in. And the last one will be kind of a timed math quiz, where we're going to ask a series of random math questions and the user will have to answer them. We're going to time them and see what their accuracy was. With that said, let's go ahead and get started and work on these 3 unique Python projects. All right, so let's begin here. Right now I'm inside of Visual Studio Code and I've opened up a directory that contains some different Python files, project 1, project 2, and project 3. Now you can write your Python code wherever you want. Just make sure you know how to run the code and you can kind of interact with the editor and all of that. So I'm sure some of you may be using IDLE, which is the basic Python terminal. That's completely fine. You can write your code there, or you can do it in VS Code like I have. Now I'm using Python version 3.9. You can use any version you'd like. And I'm just going to mention that I am going to assume a little bit of knowledge of Python. So I know that a lot of you are beginners. You may not have even written Python before, but just in the sake of time, I'm going to assume you know what a variable is, you know, print statements, inputs, for loops, kind of that basic surface level syntax, although I will of course explain everything that I'm doing. All right, let's start with project number 1 here, which is pig. I also want to quickly mention, I do have a programming course. It's called programmingexpert.io. If you guys like this style of teaching, check it out from the link in the description, and you can use discount code TIM. The big value, it has a ton of projects, a ton of practice questions, and over 100 unique videos teaching Python, Go, etc. So we want to build pig. Now, first we need to understand what this project is. So how does pig work? Well, it is a multiplayer game, first of all. Everyone plays a little bit different, but the way that I play is that you essentially get a turn. So it comes your turn and you get to roll the die. When you roll the die, you're going to get some number from 1 to 6. If you get anything other than 1, you take that and you add that to the score of your turn. So let's say you get a 5, now you're at 5. Roll it again, you get another 5, you're at 10, and you can decide how many times you want to roll the dice. Now the catch is, as soon as you hit a 1, whatever you got on your roll is going to be done. Whatever you got on your turn is 0. Like, you completely remove the score. So you can roll 5 times, 3 times, 4 times, 10 times, 20 times, as much as you want, but every additional roll, you're gambling the possibility of losing your score. So you need to decide when you want to stop. As soon as you stop, whatever your current score is, assuming it's not 0, is going to get added to your total score, and then you can determine the number of total rolls you want to have, or it's whoever reaches like 100 first or 50 first, whatever you want to do. In our case, we'll say like the max score is something like 50. Whoever hits 50 first is just the winner of the game. Okay, so how are we going to build this out? Well, let's break down the individual things that we need to do. First, we need to allow the user to roll the dice. This means we need to come up with a way to roll, so we have to have some random number generator giving us a number between 1 and 6. We then need to ask the user if they want to continue to roll. So either roll again or stop their turn. If they stop their turn, we need to take whatever their score is and add that to some total score. Then we need to constantly check if either player has a score that is above 50. If it is above 50, then we need to end the game and tell someone that they won. There's a few other things that are involved, but those are the basic steps. Let's start by generating a random number. So what I'm going to do is import the random module. Now, random allows you to generate random numbers. What I'm going to do is just define a roll function. Now, a function in Python is a reusable block of code. You make it using def, standing for define. You then put the name of the function and then a set of parentheses. We're then going to put inside of here in an indented block after a colon. So notice I'm kind of 1 tab over any code we want to run whenever we call the function. So what I'll do here is I'll say min value is equal to 1, max value is equal to 6, and then I'm going to roll the die in between them. Now there's a few different ways to do this with the random module, but I believe we can say roll is equal to, and then this is going to be random.rand, and then int like that. And then this is going to be the min value, and the maximum value of our die. Then we're simply going to return roll. Now, the way the return keyword works is it's going to give whoever called the function this value kind of back. It's going to return it to them. So if I come down here and I say value is equal to roll, the way I call the function is I use my set of parentheses, and then I can simply print out the value here. And you'll see that if I bring my terminal up and we run the code, we get the value 3. We can run it again. We're getting 6, 3, 6, 5, 5, 5, 2. Let's see if we can get a 1. Okay, it looks like it really doesn't want to give us a 1. This would have been a fantastic turn. Okay, and there you go. We got a 1, so that would have ended our turn. All right. There you go. That is how we generate a random roll. Okay, so now that we have that, we want to kind of set up the game, and we might begin by asking how many players are going to be participating. And then we can keep track of all of the different players. Maybe we set it to, say, a maximum of 4 or something like that. So let's go down here. I'm just going to zoom out a little bit, and let's set up a while loop. What we say, actually not while loop, we're going to say input. So we'll say players is equal to input. And we're going to say enter the number of players, and we'll say kind of 1 to 4, like that. And then notice I'm putting a space here at the end, just so we have a little bit of padding between where the user is going to give us the answer. So the idea is we're going to ask the user, okay, give us some value between 1 to 4. Then what we need to do is we need to check if this is a valid number. So I'm actually going to kind of put a while loop here, and I'm going to say while true, and then I'm going to put this inside. The reason for this is I want to continue to ask the user to input a number until they give me one that's valid. So I say while true, and then I'm going to break out if they give me a valid number. So I'm going to say try, or actually we can do the following. We can say if players dot is digit. Now is digit is going to tell us if this is a digit or not. So if it's a number, if it's a valid whole number specifically is what it will give us. So I'm going to say if players is digit, I'm going to say players is equal to int and then players. Now what this does is convert what's going to be a string here into an integer. And the reason I need to check if it's a number first is because if I try to convert a string into an integer and it's not a valid integer, it's going to give me an error. So I don't want to crash the program. So I'm saying, okay, if this is actually a valid number, let's convert it into that number. The reason I need to do that is I now need to check if this number is greater than 1 and less than 4. If it is, I can then break out of this while loop because I have a valid number of players. Otherwise, I need to continue to keep asking them to enter a valid player. So I'm going to say if 1 less than or equal to players less than or equal to 4, okay, then I will simply break. What the break keyword will do is immediately exit outside of this while loop, meaning we'll have access to the players variable down here, and we can just print out what the number of players is. If we don't encounter this break keyword, we will continue to ask the user until they give us a valid number of players. Now we could give them some output and say something like print invalid, try again, and we could do something here where we say something like print must be between 1 to 4 players. And actually, it can't even be a 1, it has to be 2, right? So we'll have 2 to 4 like that, and we'll put a 2, and we'll put a 2 because we need to have at least 2 players to be able to play the game. All right, so let's try this out. Let's run our code, enter the number of players. Let's enter 1. It says we need to do it again. Okay, so it didn't actually print anything out. I don't know why that happened. Oh, sorry, it's because, okay, I'll fix that in 1 second. That's an error. Anyways, we enter 2. It says must be between 2 to 4 players, which is a mistake, and then 2. So notice I made a bit of an error because I put this inside of the if statement when I wanted to put an else statement here and then put this here. Because if this is valid, we break, which means we exit the while loop. Otherwise, we tell them, okay, that was the error. So we just need to make that quick fix there with the if statement. Okay, in case you're confused, by the way, if statement checks if something is true. If it is, we kind of enter in this indented block, which happens after the colon. Otherwise, we have this else statement, which will trigger if the if statement is false, okay? So I'm going to clear and run, and let's go 1. Okay, must be between 2 and 4. Let's go 5. Let's go hello. Let's go 3, and we're good to go. Okay, so now we have the number of players, and what we want to do is essentially simulate each player's turn, where we ask them, you know, do you want to roll the dice? Yes or no? They tell us yes or no, they roll, and then we start kind of calculating their score. So let's do this. First of all, let's make some variables here. And let's say our max score is equal to, and then we can do something like, we'll go with maybe, yeah, let's go with 50 for now. We'd probably want to make that larger, but just kind of for the sake of time when we're testing this, we'll make it small. Then we want to have our player underscore scores. And what we'll do for our player scores is we'll just have a list which contains all of the individual scores. Now, we don't know if we're going to have 2 players, 3 players, or 4 players, so we're going to have this list kind of change size based on the number of players that we have. Now, the way that we can kind of create or initialize this list based on the number of players is we can say 0, 4, underscore, in, and then something like this, in range, the len of players. Now, what this is actually a list comprehension. I was thinking of the name there. What this does is it essentially puts a 0 inside of the list for every single player that we have. So what I'm doing is saying 4 underscore. Now, I could put I here, but the thing is, I don't actually care about what the variable is. I just want to do this the number of player times. So I can put an underscore essentially saying, hey, I don't really care what the variable is. So like, you know, we need to have something there, but I'm just going to put an underscore because I don't really want to use this. And then I'm going to say in range, the len of players. So what this range function will do is loop the number of players, or the length of, actually, sorry, we don't need len, just players here. It will loop the number of players times that we have. Notice that our players is going to be an int, right? So if it's 3, this will happen 3 times. If it's 4, it will happen 4 times, etc. Ignore the len that I had there. I don't know why I put that there. Just a silly mistake. Okay. So now we can print out our player scores, and you'll see that we'll get an array filled with zeros based on the number of players that we have. So if we do 3, it gives us 3 zeros. If we run it again, 4, we get 4 zeros. So now we are able to store each of our players' scores inside of this array. Fantastic. Okay, now we need to go through our player turns. So we're essentially going to say, while the maximum of our player scores is less than the max score, then we'll keep looping. Now, what max will do is give us the maximum value from this array, or from this list. So if it's 23, it gives us 23. If it's 55, it gives us that. And we're saying, okay, as long as it's less than the maximum score, it means no one's reached the max, so we'll keep going. As soon as someone does reach the maximum score, we need to stop and then tell the user whatever the, tell the players, whoever kind of won the game. All right. How are we going to do this? Well, let's go here, and we will say, first of all, roll, we'll say should underscore roll is equal to input, and we'll say, would you like to roll, question mark, and we're just going to put here a y, which means we want the user to input the key y. So then we can come here and we can say if should roll dot lower is equal to y. The reason I'm converting this to lowercase, which is what dot lower does, is because if they enter a capital Y, I still want them to roll, right? So this is just checking, is it capital or lowercase? Doesn't matter. We're going to convert it to lowercase and then check if it's equal to the lowercase y. If it is, then we're going to roll the dice for them. So we're going to say roll is equal to, and actually I can't use roll because that's the name of my function. So I'm going to say value is equal to roll. Okay. Otherwise, I'm simply going to break. And actually, a better way to do this that's going to be a little bit cleaner for me is I'm going to say if should roll.lower does not equal y, then I will break out. Otherwise, I will say my value is equal to the roll. So the reason I'm doing this is because I want to have all my code kind of not indented if I don't have to have it indented. So I'm saying, okay, if you didn't hit y, then that means we're just going to stop your turn. Otherwise, we're going to roll the dice. Now, there's a lot more code we're going to need to write, but I'm just kind of going through this as I normally would, and then we'll kind of stop and fix things as we need to. So we're going to grab that roll, and we're going to check if that roll is equal to 1. If it is equal to 1, then whatever the player's current score is just going to become 0, and we're going to move to the next person's turn. Now, we still need to simulate the turns and all of that, which we'll do in a minute, but for now, just kind of bear with me. So we're going to say if value is equal to 0, then we can simply say print, or sorry, not 0. We're going to say you rolled a 1, turn done, exclamation point. Otherwise, we'll print you rolled a, and then whatever the roll is. So we can say something like, actually, value, like that. Okay, so let's put a colon, you rolled, and then whatever the value is. All right, so now that we have this and we're kind of printing out what they rolled, I'm just going to go up here and I'm going to mark the current score equal to 0 because we need something to keep track of what the player's score is. Now, if they didn't roll a 1, then what I'm going to do is I'm going to say the current score plus equals whatever the value of the die was. I'm going to tell them what they rolled, and then down here, I'm just going to print your current or your score is, and then we'll print out whatever the current score is, and then we'll kind of continue. Now, here, I'm just going to break this because the idea is, all right, well, if you rolled a 1, your turn's done, so we're going to break out. All right, so this kind of simulates one person's turn, sorry, but again, we haven't really kind of handled the fact that we have multiple people going at once and allowing someone's turn to continue multiple times. So what we actually need to do is we need to use a for loop here. What we'll do is we'll put a for loop kind of right here, and we'll say for I in range players. So I is going to represent the current player. So we'll say player underscore index or player IDX. So player 0, 1, 2, 3, or player 1, 2, 3, 4, whatever you want to call it. And in this for loop, we'll then simulate one person's entire turn. So we'll mark the current score, but then all of the stuff that's going on here needs to happen until the player stops their turn. So what we'll do is we'll have a while loop, and we'll say while true, and then we'll put all of this here. Then outside of the while loop, we're going to say that the player underscore scores at index player IDX is going to be plus equal to whatever their current score is. So like the current score is kind of the score per turn, and then the total score is what we're going to be adding to after they finish their turn. So what we'll do after we add that is we'll say print your total score is colon, and then we will say that this is going to be the player scores at the player IDX. Okay. We'll go through this again in 1 second, but for now, we're making good progress on the terms. All right, so I'm just reading through this. It's looking okay. However, I'm realizing that if the value is 1, then we're going to have to set the current score equal to 0, just so that we make sure we don't add what their score was before they rolled a 1. All right, so let's kind of run through this here. We have our for loop. We say for player index in range players, which means we're looping over all of our different players so they each get a turn. We probably want to print out something like player, and then let's say player IDX plus 1 turn has just started, just so they know that it's now their turn. And what I'm going to do is print a \n right here and a \n. What this is going to do is just add a line break so that we have a bit of separation when the player's turn starts. So we say, okay, player, and then we're doing plus 1 because this is going to be 0, 1, 2, 3. Well, we probably want to show 1, 2, 3, 4, so that's what we're showing. So we say player, whatever it is, turn has just started. We could say player number, turn has just started. Okay, we set the current score equal to 0 for the turn. We simulate the turn. We ask them if they'd like to roll. If they say yes, or if they don't say yes, sorry, we break out. Otherwise, we roll. If they get a 1, we say they rolled a 1, their turn is done, their current score is 0, we break out. Otherwise, we take whatever the current score is and we add to that the value that they rolled because it wasn't a 1, and then we continue this whole process again. So we tell them this is what you rolled, and then we say your current score is this, which is going to be the sum of what they rolled plus, what their current score is, okay? Then eventually we're going to get outside of this while loop when they roll 1 or when they tell us that they don't want to roll anymore. We're going to take that score, add that to their total score, and then print that out. Now, we're not quite finished, but this will simulate most of the game so far. All we really need to do is determine when someone wins. So let's zoom out a bit, just so we can kind of read most of what we have here. We have our roll function. We ask the player, or we ask to input the number of players we want. We have the maximum score, generate kind of an empty list for storing the scores, and then we have this code which is going to simulate the turns. Let's run this and see what we get here. Okay, so let's zoom in a bit. Enter the number of players. Let's go with 2. Player number 1 turn has started. Okay. Would you like to roll? Yes. You rolled a 6. Your score is 6. Would you like to roll? Yes. You rolled a 4. Your score is 10. Would you like to roll? Okay, yes. Let's keep rolling. Yes. Yes, yes, yes. I'm trying to get a 1 here. And it says you rolled a 1. Your turn is done. Your total score is 0. Player 2's turn has started. Would you like to roll? Yes. 5. Okay, let's roll again. And we rolled a 1. All right. And you'll see that we can continue this, right? So I'm going to try to get a pretty high score, although this isn't working too well for me. Okay, let's stop rolling there. Now our total score is 15, player 2's turn. Okay, yes. Really gambling here. Okay, let's stop the roll. Okay, yes. Roll to 6. Your score is 6. Yes. No. Okay, total score 42. Let's roll. And no, total score is 51. And then notice the program ends here because all of the players' turns have finished and someone had a score of 51. So we end. We should really be telling them, that you won, which is what we're going to do now. But that kind of simulates the program. There's a few things we'd probably want to do to make this a bit better. For example, at the beginning of the turn, we should probably tell them what their score is so that they know that before they go into the turn so they can stop, once they hit what the max score is. Okay, so let's do this. We're going to say player 1's turn has just started. And then we're going to print here. Your total score is ... and then the player scores at the player IDX. Okay, and then we're going to begin the turn. So we can actually just remove that \n, and we'll just put one right here, just so that we kind of go one line down. Okay, do all of this. And then as soon as this ends, what that tells us is that at least one player has a score above 50. Now, multiple players can have a score above 50, and the reason this works is as soon as someone hits 50, we don't end until every player gets a turn. The reason why that's fair is because whoever goes first would have an advantage. So in this case, we let everyone have at least that last roll, and then we see whoever has the max score after the last roll. So what we can do now is we can just find what that maximum score is. We can actually get the index of that score inside of our player scores, and that will tell us which player won. So the way we do this is we simply say max score is equal to the max of our player scores, and then we're going to say player winning IDX is equal to, or actually we can just say winning IDX is equal to the player scores dot index, and we can index the maximum score. What that does is give us the index, so either 0, 1, 2, or 3, of where that maximum score is, which tells us player 0, player 1, player 2, etc. So then we can just print player, comma, winning index plus 1. So we'll say player number, and the reason we're adding 1 is because, again, we're going to start at 0. So we want to make sure we're going from 1 to 4, not 0 to 3. And then we'll say is the winner with a score of ... and then what the maximum score was. Okay, so that should wrap up the game. Let's give this one last run here. Okay, enter the number of players. Let's go with 2. Player number 1's turn has just started. Your total score is 0. Would you like to roll? Yes. Roll to 5. Let's roll again. Roll again. Roll again. And no. Okay, 16. Would you like to roll? Yes. Okay, that ended fast. You like to roll? Yes. No. Okay, and total score is 0. Would you like to roll? Yes. Okay, yes, and no. Okay, now it's player 2's turn, so let's roll. Yes, okay, that ended fast. Yes, okay, now we have the max score, so let's say no. Player 2 still gets a turn, even though we now have a score of 51. I'm just going to say no, and it says player number 1 is the winner with a score of 51. Okay, so that completes that first project. All of this code will be available from the link in the description, by the way, in case you want to download this. But I'll kind of scroll through it quickly so you can get a sense of how we wrote this. That was project 1. Hopefully you found that interesting and useful. Now let's move on to project number 2. All right, for project number 2, we're going to do that Madlibs generator. The idea is we'll have some type of story. This story will have replaceable words, like an adjective or a location or a weather condition, whatever it may be. What we'll then do is we'll ask the user to give us all of the different words. We'll then inject them in the story and then read the story back out to the user. Now, the first thing we're going to need for this is a story. So the process, as I kind of described there, is have a story with those injectable words, essentially grab what those words are, ask the user to input them, and then place them in the story. Now, I'm going to show you that there's a lot easier way to do what I'm about to do, or I'm going to mention there's a lot easier way to do what I'm going to do, but I want to show you a way that we can do it with any story. So that means that you can make this program really dynamic, and you could have like 20 stories, 50 stories, 100 stories, or you can just replace them without having to write any additional code. The way we're going to do that is by taking the story and placing it inside of a text file. That way, as long as the story is written in a specific format, we can read in the story, do the operations we need to, and then kind of run the program as we see fit. Now, what I always do whenever I need something like this is I don't write it from scratch because I'm a lazy programmer. I go to ChatGPT. So what I actually did here is I asked it using this prompt. I'm making a Madlibs generator in Python. Let's make this full screen. I'm going to need a story where the user can give me some words. Can you give me the story, even though I spelled that correctly? And for all of the words where the user needs to give them to me, make them like this, angle bracket word. Now it gave me a nice long story and it had all the different words and it kind of listed them all out. That was a bit long for me, so I said, that's okay, but can you make it in less words, please? And then it gave me kind of a shorter story. So the idea here is that whenever we have these angle brackets, we're going to kind of treat that as a word that needs to be replaced. So what we'll do is we'll take this story from ChatGPT. So I'm just going to copy this on my clipboard. We'll put it in a text file. We'll load that story in. For all of those individual words, we'll then kind of grab them, figure out what they are, ask the user to give us a word for them, and then replace them in the story. All right. How do we want to do this? Well, the way I will do this is I will copy that first of all, and I will go here to VS Code, and I will make a file called story.txt. And then I will paste that inside of here. Now make sure when you do this that you put your story in the same directory where your Python file is. So here I have project2.py and then I have story.txt in the same directory. Very important that you do that, otherwise this isn't going to work for you, okay? And if you want this story, you can go click the link in the description and just download the story from GitHub. I'll make it available for you after. Okay, so how do we do this? First thing we need to do is load this in. Now I want to load this in as a string essentially, and then be able to kind of parse through that string and look for all of those different words. Now, there's a few ways to do this, but the way I will do this is I will say with open, and I'm going to open story.txt in read mode as f, and then I'm going to put a colon. Now, what I've done here is I've used the open function, and the open function allows me to open a file. So I can open a text file, a JSON file, really any type of file I want. And the mode here, which is what I've placed second, is the way in which we're kind of reading it in. So I'm going to read it in read mode, which is R mode. If I put W, this stands for write mode, where we'd actually be creating a new file and overriding a file if it already existed with the same name. So we don't want to use W mode, we want to use R mode. This now allows me to read this story.txt file in. And the reason I'm using this with syntax is what this does is provide something known as a context for this file, which means I can do any file operations on this variable f inside of this indented block. And as soon as I get outside of that indented block, Python is automatically going to clean up the file for me, which means it will close it and make sure everything's good with the file. It's kind of best practice in terms of opening files here. So what I'm going to do is say my story is equal to f.read. Now, when I do .read, all this does is give me all of the text inside of the file. So I can simply print out story here, and you'll see if I run this, that I get my story appearing here in my terminal. Okay, so now that we've read that in, what I would like to do is look for all of the words in my story. Now, there's a bunch of different ways to do this, but essentially what we need to do is find the presence of this angle bracket. As soon as we find that, we want to find up to this closing bracket, right? So we want to find every individual word, take that word, store that in some kind of list that we're going to have access to, ask the user to give us a word to replace it with, and then go and replace all of the instances of this word with whatever the user told us. Okay, so let's do that. What we want to do is loop through our story. Now, our string, we can actually access all of the individual characters as an index. So what I can do, let's zoom in here, is say for I, comma, character, in enumerate, and we're going to enumerate the story. Now, what enumerate does is give us access to the position as well as the element at that position. Just makes it a little bit cleaner for us here. So now I'm just going to check, essentially, if this is equal to an angle bracket. If it is equal to an angle bracket, then I kind of need to do something to mark the fact that I found the start of a word, and then I need to go until I find the end of it. So we're going to set up a few variables here, and we're going to say words is equal to this, because we want to store what all of these different words are. And then what should we do here? We should say start of word is equal to -1. Okay, so we're going to have this variable, and this variable is pretty much going to tell us if we've currently found the starting index of a word. If we have, that means we can then look for the end. If we haven't, then we're going to wait until we find that starting index. So what we'll do here is we'll say if char is equal to, and I'm going to make another variable. I'm going to call this target underscore start. This is going to be equal to the open angle bracket. I'm going to have my target end equal to the closing angle bracket, just so that if we were to change the format of the story, we could easily adjust this by changing the value of the variables. So I'm going to say if the char is equal to the target start, then what I'll do is I'll say the start of the word is equal to index I. So if I found that opening angle bracket, okay, we just found the beginning of the word. Let's mark that by indicating that in our variable. Now what we'll do is we'll say if the char is equal to the target end and the start of word does not equal -1. The reason why we're doing this is we're saying if we found the ending angle bracket and we had the starting angle bracket, right, which will be marked by the start of word variable, which if it's equal to -1 means we haven't yet found the beginning. If it's equal to anything else, that means we did find the beginning. Then we can take that entire word and add that to our words list. So what we'll do now is we'll say word is equal to, and this is going to be story at index start of word up to the index I plus 1. Now what this gives us access to is a slice, which is a subsection of the string. So this is the slice operator here in Python, where we indicate the starting character, so the character we want to begin taking a slice from, and then the ending character that we're going to go up to, but not including, or the ending index. So in this case, we know the start of the word, so we put that here. And we know the end of the word because that's the current index that we're on that we just found, but we need to add 1 to it to make sure that we include this ending index in our word. So we're going to grab that. We're going to put that inside of our word variable, sorry. We're going to say words.append word, which means we're going to now add this word into our words list. And then we're going to set our start of word equal to -1 because we've now found one whole word. So now we reset the start of word so we're ready to handle it for the next character that we find, which is that opening angle bracket. So this code here will actually find all of the different words for us in the story. So let's test this by printing our words. Okay, let's run the code. And I think my terminal is a little bit cut off, but you can see that we get all of the different words. Now, what you might notice here is that we have duplicated words. Now, the reason we have duplicated words is because this word could appear multiple different times. Now, that's fine if it does, but I only want to have the words that are unique. Now, the way that we can essentially do this is we can change from using a list, and instead we can use a set. Now, a set is a data structure which will only contain unique elements. So if I add the same element in, it's not going to do anything. We just have one instance of each unique element. The way to do that is just to write set here instead of a list. And then rather than append, we're just going to say add. Now add will just add this to the set. And you'll see now that when we run this, we'll just get all of the different unique words. Perfect. Okay. Now that we have those words, what we want to do is ask the user to give us a value for each of the words. So the way we'll do this is we'll set up a dictionary. So we're going to say answers is equal to a dictionary. The idea is we want to have the word as the key. So something like name. And then the value in our dictionary will be whatever answer they gave us. So something like Tim. The reason we'll do this is so we can very easily look up the value of a word. So we say name, Tim, blah, 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 okay? And then what we'll do is we'll take whatever these values are and replace them in our story later on. The way the dictionary works is you add a key by doing something like this. Answers key is equal to, and then whatever the value you want. And you can access the key by just using the square bracket syntax like this. Okay, so we have our answers. This is going to be an empty dictionary. What we'll now do is we'll loop through all of the unique words that we have, and we'll ask the user to give us a value for them. So we're going to say for word in words, iterating through our set, and we're going to say answer is equal to input, enter a word for, and then we're going to do plus, and then whatever the word is. Now, notice we can't do a comma here because we're using the input statement, not the print statement. So we need to concatenate, which means add two strings together. So we take the word, add it to enter a word for, and then we can just put here a colon with a space at the end so that the user knows where to start writing. Okay, so that gives us an answer. We're then going to say answers at word is equal to answer. And let's spell answers correctly. Okay. That will now create a dictionary that has all of the words associated with all of the values. So let's now print out answers. Okay, so let's come here. It says enter a word for object. Let's go something like chair, weather condition, sunny, adverb, I don't know, let's see, gently, place, school, emotion 2, sad, animal, bear, place 2, I don't know, house, terrain, what is this, grass, okay, character, Tim, adjective 1, jumps, emotion, happy, and there you go. It gives us now all of the different words and their answers. Now that we have that, we can take every single instance of these words and essentially kind of replace them in the story. So now we're going to have another for loop, and we're going to say for word in words. Now, the great thing in Python is that we have this method called replace all, or replace. I don't know which one it is. I think it's replace all. Either way, what this is going to do is replace every single instance of one string with another. So that's super convenient for us because we know the string we want to look at, which is that kind of angle bracket, and we want to replace that with our answer. So now what we'll do is we'll simply say story.replace. I think this replaces all instances of it. We're going to check that in 1 second. And we're going to replace our word, which is that angle bracket string, with the answers of our word. And then we can just print out our story and we'll be good. We'll have the entire program finished. So let me quickly run through the code and then I'll show you how this works. So we open up our story.txt, we read this in, we create a set of all of our unique words. We then say the start of the word is equal to -1. We have our target kind of opening bracket, target closing bracket, and this first block of code here goes and locates all of the different words that are inside of our story. So we say for I, character and enumerate story, getting the index as well as the value. We say if the character is equal to that starting kind of open angle bracket, let's mark that by saying the start of word is equal to I. Then down here, if we found the ending bracket and we had the start of a word, we've just found the end of the word. So now what we can do is grab that word using our slice syntax, add that to our set, and then reset start of word. Then we have all of our words, so we need to generate an answer for them, which we ask the user to do. And then we simply go through and replace all of the instances of our word with the answer the user gave us. Awesome. Let's give this a shot. Let's make this full screen and run. Animal, bear, adverb, gently, character, Tim. I probably should do lowercase for it, but that's fine. Weather condition, sunny, terrain, grass, place, school, adjective 1, I don't know, throw, emotion 2, sad, place 2, let's go with soccer field, emotion, happy, object, chair. Okay, and unfortunately, it seems as though this actually didn't work. So I'm gonna have to look at what the problem was here. I already know what the issue is. So I said story.replace. However, what this does is this gives me a new string. So what I was doing is I was just kind of generating a string that I wasn't storing anywhere. So story didn't change. This gives me a new string. So what I actually need to do here is say story is equal to, and then story.replace, and then do this. Now there's more efficient ways to go about doing this, but this will be perfectly fine for our purposes. So if we fix this up now, and let's save that. So again, just we kind of are now changing the story every time by updating that variable. What I'll do is run this again. Emotion, sad, adjective, throw, character, Tim, place, school, terrain, grass, place 2, soccer field, object, chair, adverb, gently, emotion, sad, animal, bear, weather condition, sunny. Okay. In the throw land of school, adjective, okay, I probably used the wrong thing for an adjective there. Anyways, in the throw land of school, a bear was feeling sad. The bear had lost its chair. Suddenly, a Tim appeared. I will help you find the chair, they said. Together, they journeyed through grass and faced the sunny. Okay, I probably should have said, like, raining or something. Finally, they found the chair in a soccer field. The bear was so sad and thanked the Tim. They lived gently ever after. All right, you know what? That's not so bad. I think there was a few words that I probably messed up writing, but there we go. We get the story, and yeah, there you are. Now, if you wanted to, you could store that in a text file, but I think that pretty much wraps up this project. That was pretty cool, and obviously, if you kind of change the story around and give some better words, you could get some pretty interesting results there. Regardless, hope you guys enjoyed. Let's move to the next project. All right, so let's get into project 3. Now, the idea for project 3 is we want to randomly generate a bunch of different math questions, ask the user those questions, and then not let them continue until they get it correct. will then time how long it takes them to answer all of the questions. So the first thing we need to do is be able to randomly generate these problems. Now, there's a bunch of different parameters we can use, right? We have a set of operators we can use. It's like plus, minus, addition, multiplication. We could even use exponent and stuff if we wanted to. And then we have kind of the max values as the operands, like the min, max value, etc. So what I'm going to do is write a few variables that we'll use as constants that we can change that will make this either easier or harder, depending on what you want to do. Now, first of all, we're going to need random because we're going to be randomly generating operands. Then we're going to need the operators. So I'm actually going to do this in all capitals. I'm going to say operators is equal to this. And then I'm going to say min operand and max operand. Okay. We'll say for the min, maybe we have a min value of 3. And for the max, we'll go something like 12. For the operators, I'm going to use a string. And I'm going to put in Python operators. Okay. It's important that these are ones that could actually be used in Python, because I'm going to show you the way that we'll actually figure out what the answer is. This is not going to be that long of a project, but it'll show you a cool function that you might not have seen before in Python. So what we're going to do is write a function called generate problem. Okay. Now what this is going to do is generate a problem for us that uses one of these operators and then a random operand on the left and right side. So we're going to say left is equal to random.randint. And this is going to be the min operand and the max operand. We're then going to say right is equal to random.randint. And again, the min operand and the max operand. Now, I'm actually going to remove division because I'm realizing that the way I'm going to write this is not going to work too well with division. We need like a separate set of parameters. So for now, we'll just use these 3 operations, which I think is fine. Okay, we're then going to randomly select an operator. So we're going to say operator is equal to random. And there's actually this function called choice. What this does is just randomly pick one of the elements from a list. So I can say random.choice operators, and that'll just give me randomly one of these. Then I'm going to say my expression, which is XPR or EXPR here, is going to be equal to the left plus the right plus the operator. However, I need my left to be a string, and I need my right to be a string. Okay, so this is going to give us the expression, which will be the left-hand side plus the right-hand side. And what we'll actually do is we'll just add a space in between here so I can print this out and you can just see kind of what it looks like. So let's add a space like that. Okay, so now let's call generate problem and let's just print out the expression and then return it just so we can see what that is. Okay, so clear and Python project 3, and I got an error, can only concatenate string, not int to string. Okay, sorry, that's because I put this in the wrong order. So operand, or operator, sorry, plus the right. Okay, so let's fix this and run again, and we get 12 plus 9. Let's run a few more times, and you can see we're kind of getting random operands and random values. Sweet. All right, that's working. Now the question becomes, okay, we randomly generated this, but we need to know what the answer is, right? Since we're randomly generating it, it becomes a bit more difficult to calculate the answer. Now, what we could do is just use a bunch of if statements, right? And I can say if the operand is plus, add them together. If it's minus, subtract them. If it's multiplication, multiply them. That's fine. However, I want to make this a bit more dynamic such that we can kind of make this a bit larger and we don't have to do all those if statements. Now, the way to do that, so we can actually do this. We can say answer is equal to a function called eval. Now, what eval does is evaluate a string as if it was a Python expression. Now, notice we have an expression that is valid Python code. Like 6 minus 12 is valid code that we can evaluate. So all I have to do is put this expression inside of the evaluation, and it actually just tells me what the answer is. So now what I can do is I can return my expression and the answer like that. And if I go here and say expr answer is equal to that, I can print them out. So I can print the expression, excuse me there, sorry, but I can print the expression and the answer, and it will tell me what it is. So I'm just showing you how we can kind of avoid having like, if it's this, do this, otherwise do this. That's fine, that's valid to evaluate it that way, but we can use this eval function. So if I run this, I get 7 minus 3, that's 4, right? 12 minus 4, 8. 10 plus 5, 15. So I figured you guys would find this eval function kind of cool. Hence why I wanted to show it to you. All right, so that is our generate problem, and that's really most of the coding done. What we need to do now is determine the total number of problems. We then essentially need to set the timer when the user begins, and we need to ask them to answer it, right? So what I'm going to do is say total problems is equal to 10. Set this to whatever you want, but the idea is I'm putting all of these capital or all capital variables at the top of my program. These are constants, meaning they're not going to change, and we can simply change them around like once we're kind of going to run the program a second, third time to make this more challenging, easier. Like we can set the parameters of the program from these variables right up here. Okay, so now that we have that, what we'll do to begin is we'll kind of just ask them the number of problems, then we'll set up the timer. So we're going to say for I in range, and then this will be the total problems. And then we'll print something like this. So we're going to say expression answer is equal to generate problem. So that gets us a unique problem. We're then going to print problem number, and then we'll say plus I plus 1 inside of parentheses, and this will need to be a string. So what we're doing is we're converting I plus 1 to a string, so it'll be like problem 1, problem 2, problem 3, so that they know. Then we're going to say plus a colon. Now notice the reason I'm using pluses here is because I don't want to have a space between my different values. I just want to have them kind of in line. So I'm saying problem number 1 colon space plus and then the expression. Okay, and then we'll put, actually, I'm realizing we're going to put this inside of an input statement. Sorry. So we're going to switch this around, and we're going to say guess is equal to input, and then we'll have plus the expression plus a equal sign like that. So now what we're doing is we're saying, okay, problem number 1, here's the expression, so here's the problem, equals, and then the user can type in their answer, and then what we'll do is we'll keep asking them this until they get it correct. Sweet. So then inside of here, we'll do a while loop, and we'll say while true. We'll do this. We'll say if guess is equal to answer, then we will break. Now, the thing is, our answer is going to be an integer, but our guess is going to be a string. So we're going to convert our answer into a string so that we can compare the same types. Because if you compare an int to a string, even if they're the same value, like the string 10, the number 10, is going to say false. Now, I want to convert the answer to a string, not the guess to an int, because if I tried to convert the guess to an int to match the answer type, and they had typed in something that wasn't a valid int, then that would crash my program, which I don't want. So this way, I'm kind of solving for that. I'm going to make sure that I don't have any potential crashes. Okay, so if they get it right, break. Otherwise, we're just going to keep asking it to them. We don't need to give them any feedback. They can just keep attempting the answer. Okay, so that's good. And I think that's actually going to be it for all of our problems. All right, so let's run this now, give this a shot. Now, I'm about to embarrass myself. I haven't done math in so long, so let's hope it gives me some easy ones. Okay, 9, 5 times 8, 40, okay, 20, 10, 8 times 7. I always mess these ones up. Not 64, 56, okay, 88, and there we go. We finish the problems. All right. So that was actually pretty good. Did I get any wrong? No, I didn't. Okay, let's try it again. Let's get one wrong this time. And notice it's going to keep asking until we get this correct, and then we continue. Okay, I'm just going to hit Control-C to exit out of that. And now what we'll do is we'll set up the timer. Now, I would love to make it so the timer, like, it shows you the timer. It's going to be a little bit difficult to do without going into some more advanced code. So what we'll do is we'll just start the timer as soon as they say, like, they're ready to start, and then we'll tell them what their time was at the end. And we can also tell them, like, number of correct answers. So let's do something like this. We'll say wrong is equal to 0. And every time they get it wrong, so we can just go here and say wrong plus equals 1. And then that way we can tell them kind of what their accuracy was at the end. All right, so wrong. We're also going to import time. All right. And now before we start doing all of this, we just want to ask them, like, okay, are you ready to begin? As soon as they hit enter, then we start the timer, just so they have a second to like gather themselves before it begins. So I'm going to say input I'm going to say press enter to start. Okay, really they can press anything they want and it's going to continue as long as they go to the next line. So they could type something in if they want, doesn't matter. So press enter to start. We'll print out like this, okay? And then it will begin, and I'm just going to take this and print it once they're done. And then we'll print, nice work, and then whatever else we want to do. Okay, so as soon as we do this, so as soon as they hit input, we're going to start the time. Now I imported this time module, and what I can do is I can say the start time is equal to time.time. Now this is going to give me what's known as the Unix time. Yeah, I think that's what it's called. Let's see here. So actually, sorry, it says return the current time in seconds since the epoch. Don't worry too much about exactly what that means, but it's going to give us some kind of timestamp in seconds. So what we do is we kind of mark the start time. Then we just need to figure out what time they ended at. Then we subtract the 2 times, and that tells us the total amount of time. So as soon as they finish the for loop here, we say end time is equal to time.time. And then we just say total time is equal to the end time minus the start time. And then we can print out how long it took them. So we'll do that down here. Nice work. You finished in, comma, total time. And we'll do comma, seconds, like that. Now we could parse this and do minutes, hours, etc. But I think just doing the number of seconds is fine. And that will be our program. Okay, let's give this a shot. So run the code, press enter to start. Okay, so that's 80. That is 17, -2, -6, 11, 77. Fortunately, it's giving me some easy ones here. 16, -3, 36. Okay, nice work. You finished in 16.95, blah, 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 whatever seconds. We could probably round this off if we wanted to make it a little bit better. So let's do that. And we will take this and round this to the nearest 2 digits. Okay, let's do this one more time. See if we can beat our time of 16 seconds. That was pretty fast. I don't know if I'm going to be able to do that. Okay, -2, -1, -1. Oh, what am I doing? 1. Okay, definitely not going to win now. 49, 14, 30, -4, 12, 0, 10, 21, 17. Oh, I was pretty close, even with that mistake. I was reading it as 7 - 8, not 8 - 7, hence why I made the mistake 3 times. Anyways, that was pretty good. All right, so that completes our program and all of our projects. Now, I realized I kind of ended up doing the projects in the reverse difficulty order, where the first one was the hardest, second was medium, last one was the easiest. Anyways, I actually had a lot of fun building these projects. Like I said, I haven't done any of them before, and I hope that you guys enjoyed this video as well and kind of got the taste for how I write code, how I come up with the solution, how I break this down. To be honest, this is relatively simple for me. A lot of this, doesn't require a ton of thought, but I hope for you guys that it was valuable and you can kind of see how you even make variable names, how you structure things into functions. I could clean this code up and make it a lot better, but I wanted to kind of, blur the line between what could be expected of a more beginner programmer and what are some better practices when it comes to coding. If you guys want any of the code, it will be available from the link in the description. Let me know if you enjoyed these projects, if you extend them, if you're working on some other cool projects. Always love to see your comments. Again, if you guys want to check it out, I have that programming course, programmingexpert.io. That'll be available from the link in the description. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.